So I'm here to talk about the riparian component of this T3 study, and I'd like to acknowledge all the other principal investigators. Uh, they've gone a long way in developing this study along with me, Bernard, and Jenny. So as most of you know, riparian areas are managed differently than upland studies or upland forests and stuff like that. They're more for ecological purposes rather than harvest operations in the past. Uh, Traditionally, this is done by creating riparian buffers. And these buffers really have two different types of purposes. One is to restore the functions lost from past riparian harvests and create more of a diversity in forest types. As you saw from Bernard's presentation, a lot of our forests are geared towards younger forests these days, and we lack a lot of those older forest component. And then we also want to maintain and protect against whenever we have upland harvest next to our streams, that we protect against any negative effects from those operations as well. And with this study, we really want to ask the question, are there better ways to protect and improve conditions in our riparian forests? So there's two kind of ways we go about protecting and restoring our forests is through passive and active restoration. And they all have their pluses and minuses. So passive restoration, we know it's going to take a very long time till we get these old growth forests back in our riparian areas. It'll take over 100 years, but it's a very cheap method of doing it, just letting the forest there. And nothing tends to be more successful than nature at restoring its own functions. Active restoration can work very quickly, but it is also expensive. You can create conditions outside of the natural range of conditions, and you may help one species while hurting another species. What we found from our earlier work on the OSF, and a lot of this was talked about by Warren Devine in the very first presentation today, but what I'm going to show you here is some data from our first study where we compared earlier work done, earlier work done in the 70s in areas that were harvested and reference areas to our initial findings within the OSF validation monitoring program and stats and trends program. What we found is compared to the 70s, our in-stream wood levels have gone down. Our canopy coverage is really gone up from what it was in the 70s. And the harvested areas in the 1970s, you had kind of the lowest levels that we found, and then they've gone up past the reference conditions and now to this kind of really high level into the high 90 or the 90s level of percent shade in our streams. With that, we've seen our stream temperatures decrease as well. When it comes to fish, we've seen kind of a mixed response. So in the top graph here, you see our age 0 fish numbers are very similar to what we found in the 1970s. This isn't really too much of a surprise because age 0 fish don't need very complex habitat. They like shallow stuff and they just hang out in there. If we look at our coho fish in our center graph here, we see that our numbers are fairly reduced from the 1970s period. What we don't know is what's causing this reduction. Coho salmon have an anadromous component and go out to the ocean. There's lots of places where things have gone wrong in the past, and that could be reducing these coho numbers. What I find the most interesting is our age 1 and older cutthroat numbers. These fish have spent their entire lifetime in these streams, so they're suited to they've kind of gone into the habitat and have experienced the habitat as best they can. And we know the age 0 numbers are fairly high or similar numbers there, but our age 1 and older fish seem to be reduced. And this could be due to the decreases in wood or that really high canopy coverage that could be blocking the sun and some of the productivity in these smaller streams. So now that we've got some background, these are the strategies and the prescriptions that we're proposing for riparian treatments. Alternative 1 is our active habitat restoration treatment. We just have one prescription within the strategy. Alternative 2, we have 2 prescriptions. So we have the variable width buffer and the alder rotations prescriptions under this strategy, where the alder rotations will be done in the lowest tributary of this watershed. And then the variable width buffers will be done in the remaining upper portions of this watershed. We do have our standard OSF buffers and then a no action control. So here's our active habitat restoration prescription. What we plan to do in here, and I should first note this is only going to be applied to fish-bearing streams, since this is going to be an active treatment to increase fish habitat. So we're going to create one gap per every 100 meters of buffer. And it'll be a fairly aggressive gap, about 30 meter by 30 meter. This was, we came to this number after discussions with scientists at OSU and the USGS. Within each gap, we're going to put 3 wood jams per gap. And then the remaining area next to the stream will have a 7.6 meter, 25-foot, no entry stream side buffer. And then we're also going to do light thinning on the outer portions of the buffer. And what we expect to see with this treatment is it's going to be an active restoration treatment. We're going to increase wood in the stream both immediately and in the future. So we're going to put wood in the stream, so that'll be immediate, but that thinning will allow these trees to grow bigger and contribute into the stream. That gap is going to increase light in the stream and hopefully just enough to increase productivity without hurting our stream temperatures, which we're in pretty good shape right now. The thinning and the gaps are developed to create more structural diversity, something similar to what we'd find in an old growth style forest. So creating types of forests that we don't have a ton of on the OSF. Now our hope is that this additional work within the riparian buffer will not only pay for the restoration, but also increase a little bit money to the communities as well. Okay, our alder treatment. This was going to be in the lowest tributary of these watersheds. This one's going to be applied to all streams. It's going to involve very heavy thinning down to about 30 trees per acre, and then they're underplanting alder. And this is what we expect to see with this one. It's active restoration again. It's going to increase existing the tree growth, so those conifers that we leave in there are going to grow a little bit quicker. It's going to increase nutrients into the stream because alder is a nitrogen fixating plant, so it's going to put more nitrogen in the soils and in the stream. It's going to add more leaf litter in the stream, which can increase bug production in the stream and increase the amount of terrestrial insects falling into the stream. This will also provide a short rotation crop of alder for increased revenue. So this could also get us more of that structural diversity that we're lacking in those old growth forests. However, it could also create us more in a very canopy closed stage with alder as well. So that's part of the experiment, what we'll learn. The next prescription in alternative 2 is a variable width buffer. So the buffer width will be determined based on the size of the stream. And it'll initially range from about 60 to 100 feet. Now we're going to loosen protections if it's a high gradient stream with small, that's not very wide, where we only expect to find cutthroat trout, which are very abundant in the OSF, or if there's no fish present. We'll add protections for things like unstable slopes or if there's a high potential of wind throw. We'll also add protections if over 20% of the watershed has been harvested over the last 10 years. So if it's been harvested a lot, we don't want to put too much more stress on that system. In addition, if in our lower gradient streams where we think we may have more stream temperature concerns with additional harvest closer to the stream, we'll also add more buffer width. So our expected results with this, it's more of a site-specific riparian buffer. So we feel that smaller streams don't need as much protection as our larger streams, and it's probably related to the size of the stream, the amount of buffer protection. So this will kind of test a little bit of that. Since this isn't community inspired, it is more an aggressive treatment and is aimed more at creating more revenue for the trust as well. Our next treatment is the OSF management treatment. First thing I want to mention is that our forest land plan actually allows for many different types of treatments that can be done. This is just one of the more common one that's done in the past. And what we're calling this is our 30-meter or 100-foot no-touch buffer. And we had to standardize this for the sake of the experiment, that we just couldn't do too many prescriptions because we'd have to test them all differently, and we just had a limited amount of resources. We do expand the widths of our current buffer for unstable slopes and when there's a high chance of wind throw. This is an example of passive restoration. With this, our expected results for recovery wouldn't happen for another 100 years with our riparian forests in the conditions that they currently are. And this is going to not only evaluate our current management, but also act as a control against the alternative strategies that we proposed earlier. Finally, we have our no action control. So basically these watersheds, we're just going to leave it alone and just do some monitoring in there. This is another example of passive restoration. We do admit this will maximize carbon sequestration, but once again, we won't expect stream habitat to improve for another 100 years. We should also mention this is not currently a viable management strategy due to the DNR's trust mandate, but it also provides contrast with our other treatments.
Kyle, just to interject that you have about a minute.
Perfect. So here's our sampling design. Basically, we sample 2 reaches within each watershed, once at the sampling reach, and then once at what we're calling our pour point, or the lowest portion of the watershed. The one exception is that an alternative 2, where we have the 2 different prescriptions, we'll just sample at the reach locations there. Monitoring will go, we started treatment monitoring last summer and will continue this summer. Treatments will go in the fall of 21 to 23, and post-treatment monitoring will happen in 23 to 27. And here are a quick look at what we plan to be, or we are monitoring. So we're doing salmonids, density and biomass, stream temperatures, aquatic invertebrates through Elsa's work at WSU, stream characteristics, so pools, rapids, runs, in-stream wood, periphyton, riparian vegetation, canopy cover, stream sediment. And if other people have something that they'd like to monitor in these watersheds, we more than welcome your involvement with this study.